Thanks for coming to this video, which I'm titling More on Detectors. It gives me an opportunity to talk a little bit more on the radon detectors that we mentioned in the earlier video. And I hope to elaborate and expand on some of the topics dealing with detectors that I mentioned before. Now, fundamentally, there are four measurement methods or four measurement detectors that I'm going to talk about. The charcoal devices, liquid scintillation, which is also a charcoal device, alpha tracks, and continuous monitors. I'm not going to discuss much about what happens in the laboratory as far as analyzing the detectors, but the nuances that pertain to us as we go to deploy and retrieve the detectors. Now, I already talked about the charcoal devices before, and I'm going to talk about them again, obviously, here. And if I take a charcoal can, and we've seen this particular can before, this guy's been sealed and unsealed 100 times. When you get the can, it comes with a seal on it. And to deploy it, you simply remove the seal. I usually put it at the bottom so I can find it again. And you deploy it in the room and in the location that you've chosen. Now, the way they work is there's some charcoal in the can, and it absorbs the radon. That is, the air comes through this opening and passes into the charcoal, and the charcoal holds onto it. Now, I'm going to show it to you. Now, you never do more than what I've just done here. You simply always just unseal it, and then when you're done with deployment, reseal it. But I thought for excitement, I would open the can up for you and show you what's inside. So you can see that there's nothing very special here, although the can is well thought out. I'm going to open the lid. And when I open the lid, I think you can see that there's a nylon mesh here. You can see it on both sides. And the purpose of that nylon mesh is so that as the air diffuses into the can, it has to go through the nylon mesh. And that nylon mesh will prevent much of the water vapor that's in the air from getting through it. Then, as you look in the can a little bit further, you will see this in this particular can design. There are numerous can designs. In this one, there's a little bag of water vapor absorbent called sorbate. That's the manufacturer's name, sorbate. And this too captures water vapor and helps prevent it from getting into the charcoal. The goal here is the charcoal that's going to absorb the radon gas will absorb any gas, including water vapor. And if a lot of water vapor gets in, it will occupy many of the sites that the radon would otherwise cling to, and you would collect less radon. So in order to prevent that from happening, or at least diminish that from happening, these diffusion barriers and sorbate bags are put in to help diminish the effect of water vapor in the can. And then if you look further in the can, you'll notice there's a wire mesh, and that mesh is there solely to keep the charcoal in place. And you'll notice possibly there's a little bit of caulking along the outside of the wire mesh, and the purpose of the caulking is to just keep the wire mesh in place. And then under that is simply the charcoal. And that's it for the whole can. Now, when you buy these cans, you typically, if you go to the local hardware store, I wouldn't. I'd go direct to the lab because the lab can probably give me a pretty good discount. It comes like this. And the can's inside a bag with a set of instructions and a form that a homeowner would fill out. But you, testing for radon in schools, will use the device placement log instead. So you won't need the form that you fill out, but the instructions will be very useful. You just rip open the bag, and then you have the can comes out of the bag, and then you're ready to deploy it. Now, when it's time to return it, that is, you've gone back at the end of the deployment period, you've resealed the can, you've filled out the device placement log at that moment, and at the end of the day, you've collected all the cans, they're ready to go back. They don't go back into another bag, they just go back just this way. You pack them all up in a box and send them back to the lab. I want to spend just an extra minute on the plastic trays, because we've seen some problems with the plastic trays with sealing them up when they're done. When you get the plastic trays, they will come like this. They're in a bag. And you'll notice that there's an envelope in the bag, and there's also, you might be able to notice it, some instructions inside the bag, much like the charcoal can. And when you rip this open, what you get is another bag along with a set of instructions and a form to fill out. Of course, you won't be using this form, although you will look at the instructions at least once or twice to make sure you know how to use these. But the tray comes in another bag. And when you go to deployment, what you're going to do is rip open this bag, and at that point you have just the tray. And then this tray is deployed, and for whatever number of days you've chosen, at least 2 days, right? A minimum 48 hours. And then when you're done with the deployment period, you're going to take this, and this is the part that's been mistaken in the past. You're going to take this and you're going to put it in to this aluminized bag which came with the kit. You're going to slip it in here. I know I described this earlier in the earlier program. I'm doing it again. And you seal it up, and then you can send it back. There's room for the serial number of the detector on here, and you'll put it on this bag. And then this, after they're all sealed, and you have your 100 or however many, you can put them in a box, and you can send them back, along with, of course, a copy of the device placement log, properly copied, right? So I wanted to say those things about the charcoal devices because you have to be careful about deploying them, retrieving them, and sealing them somehow so that you can send them back. Now, the next charcoal device I wanted to show you is called a liquid scintillation device. I show it to you here in this picture, but better than that, I've got one right here. So I've got one right here. That's all there is to it. Now, this is actually a charcoal collector. It says liquid scintillation. However, that's the way the lab analyzes it, which is frankly of little interest to us. But the way this is, I'm going to open it up. The way you get it is it comes like this. And to activate it, all you have to do is unscrew the cap and deploy it in whatever location you want. When you're done, after your few days of deployment, you come back, you put the cap back on, and now it's sealed. And it'll be returned to the lab like this. Now, they come with a barcode on them. This one is missing the barcode, but they come with a barcode on them, and the barcode has a lot of the information it needs, and including a serial number, which you will, of course, put on the device placement log. Now, I just want to show you what's inside, and bear in mind you would never do more than what I've just done, which is just unscrew the lid. That's all you do as a tester. But just so you can see what's inside, I can remove this pink foam that acts as a diffusion barrier. Take that out, and then there is actually nothing else in there except a little bag of charcoal that you can see, and there it is, pops right out, and it has a few grams of charcoal. And this charcoal works just like the charcoal in the can. It's simply a smaller amount, and works very well. Now, when this goes back to the lab, there's a number of different things that happen to it that don't happen to charcoal canisters, and I'm really not going to get into them very much. Here, I'm going to look at the alpha tracks next. We talked about the alpha tracks, excuse me. And I just want to talk about it one more time. The alpha track, it comes in a plastic bag, and it comes like this. To deploy it, all you do is rip it out of the bag, and you can hang it, or you can place it lying this way or this way. And then the radon and the ear will diffuse into the volume in here through the little slit. And of course, inside is there's nothing inside besides this little plastic strip. That's all you get. And the little plastic strip is sitting in here like this. I'm going to show you. And the lid's on top of that. So you never open this lid. You never do that. I just did that to show you what's inside. And when you're done, you just take it, you put it back in a plastic bag or whatever device they give you with which to seal it, and you send it back to the lab along with the appropriate device, your log sheet. Now the Alpha Tracks, you can buy the smaller ones like this. There are larger ones out there that look like this. They're actually significantly bigger. And some of them come just as you see here. Let me just get over to that. So here we have the detectors, a couple of Alpha Track detectors that I'm showing you. This one's by Accustar, and it's the one we've looked at in some detail. This is by another company, and these are called Rad Tracks. Just to point out a difference between these two here, this model has holes cut into the cap of the device for the air to diffuse into the detector chamber, and it has filter paper across the top to prevent radon progeny from getting into the chamber right off. Now, progeny will be created by the radon as it decays within this volume, so we'll get some alpha particles emitted by the progeny in both cases. But just to recognize that some designs are a little different from other designs. Those that are unfiltered are typically identified with the letters UT. So don't let those letters be a distraction to you. With regards to the accuracy of all devices used in Pennsylvania, the maximum accuracy must be within plus or minus 25% of the correct value. And I can tell you that many, in fact, most detectors used in Pennsylvania have accuracies much better than 25%, and many of them come in with accuracies in the single digits, 3, 4, 5, 7% accuracy. So the accuracy is not an issue for these detectors that are approved to be used in Pennsylvania. And I believe that is true for all of the detectors that are approved by the National Radon Safety Board and the National Radon Proficiency Program. Now I show you a slide of the plastic strip that you saw earlier in one of those detectors after it's been treated so that the scratches are now visible. And these scratches are counted by using automation. They're not counted by hand. N represents the number of scratches that you would see on the device. But what impresses me most about this slide is that every little pit that you see here is a pit caused by an alpha particle striking that plastic strip. It actually, that alpha particle, makes a scratch mark on the plastic. And the alpha particle's incredibly tiny. And if an alpha particle can make a pit on a plastic strip like this, imagine what it's doing to your lungs. Next, I want to look at continuous radon monitors. Now, there are numerous kinds of continuous radon monitors, and I do not have a sample here for you, but recognize that this one here is a fairly common radon monitor, continuous radon monitor. It's about the size of a large book. And what's nice about this monitor is, first of all, it's electronic. It can be run on batteries or plugged in, and has no charcoal in it. What it has in it is a small volume that's surrounded by metal plates that I call the sensitive volume. And room air will diffuse into that volume. It'll diffuse throughout that device, actually, but of course, I'm concerned about what goes into the volume. That sensitive volume goes into that volume. And when the radon decays and sends off an alpha particle, the alpha particle scoots across that volume and can strike a metal plate. If it gets to the metal plate, it'll actually produce a voltage pulse. And all of the electronics in that device are there to count that pulse. And the more pulses it sees or counts, the more alpha particles were striking the metal plates, and therefore the more radon was in there. And from that, the software in the unit identifies what the radon concentration must have been. It makes hourly averages so that you know hour by hour what the radon concentration in the room is, or at least the concentration in the vicinity of that particular device. And so it's called a continuous radon monitor for that reason. That is, it counts hourly and gives you the hourly averages. Now, this is a tape of what it would look like, and I'm going to enlarge that for you so we can read that more easily. And you will see here, it's got start date, start time, and all these other parts to the issue. But what I want to look at is the graph for a moment. And the graph needs to be read sort of on the slant. Obviously, you would take the strip of paper and rotate it so you could read it. But radon concentrations are horizontally here, and time is down the strip this way. And you can see here that initially the radon concentration was around 2, and then a little later it was a little bit more than 2. And you can see it's actually going up a little bit till it starts leveling off, excuse me, around 3 picocuries per liter. Now, what's nice about this device is because it gives hourly averages, you can tell whether or not the radon concentration in that room or the vicinity of that device was in the daytime, in the nighttime, during what hours was it largest and smallest, etc. The one concern, the one issue is that there's a thing called ramp-up time involved with these devices. That is, let's imagine for a minute you bring it in from your car, you deploy it into the room, you plug it in, you turn it on, and there's a little display that tells you what the radon concentration is in the past hour. That shows up, along with the paper strip. The ear that's in the monitor initially in the first hour is a mix of the ear that was in the monitor initially, which let's say is outside ear, and then the air in the room. So it's not a good representation of the radon in the room in the first hour, or even the second and third hour. And so I've drawn here sort of an idealistic version of what this might look like on a paper strip. And I started at 0, which is obviously a silly value. You'll never see a 0. But it goes up a little bit here. In this example, it's a little over 2 and then almost 4, and then it's leveling off. It happens to be leveling off at about 4 picocuries per liter. In other words, there's a ramp-up time. And typically what's done is the first 4 hours of reading of the device are simply discarded, because they're a mix between the outside air and the air that was in the room to start with. That is called the ramp-up time. And if you get to use one of these devices, you need to be made aware of that. These devices are typically used for diagnostic work. They're not typically used for short-term testing, not typically, because the device is fairly expensive. And it's obviously far more economical to deploy some passive short-term detectors like the charcoal devices instead of this. And that's pretty much everything I wanted to add on monitors. The truth of the matter is, I could talk about monitors and devices to measure radon all day long. There are tomes of work done on these different devices and how they work, but I think we've done enough. Thanks for listening.